Hello friends, Dr. E here. So I took a group of Harding students to LA last week, and I caught something. I'm not sure what it is, but I've been sleeping most of the week. In between taking naps, I've been working on material for the other classes. Not so much for your class, because I situated your class 2 years ago for this kind of development. So you guys are the lucky ones. We get to finish out the semester. We're going to try to do all of the material, and we'll see if we can get there. I think we can. I hope you guys are safe. I'm starting to feel a little bit better. Don't think I have the bad virus, because I haven't had any fever. And I haven't had any shortness of breath. As you can tell, when is Dr. E ever short of breath? Well, maybe I'm short of breath, but I'm never short on words. So, let's do some homework. And for Chapter 5, we'll start with homework number 1. That's a good place to start. So, again, I hope you guys are safe, and I hope you're doing okay. I hope your loved ones are well also. All right, so how do you know that a question is a future value problem? A future value problem. So it's really important to get the language right. Understand what kind of question you're dealing with. So the question will provide the beginning dollar amount, and the question will ask what the ending dollar amount will be. It gives you, the question gives you the starting amount and asks what the ending amount will be. That is a future value of a lump sum, one sum. All right, speaking of that, how do you know that a question involves a lump sum? Only one amount or deposit or contribution is involved. One amount, a beginning amount. You're asked to solve the ending amount, but there's only one amount that you start with. No more money is put in, okay? All right, you deposit $500 into an account. The account pays interest of 7%. How much will the account be worth in 1 year? Okay? And so the formula for future value, the future value equals the present value times 1 plus I raised to the n. I is the interest rate, n is the number of pay periods. Okay? So in this situation, we have $500 times 1.07 for 1 year, and we have $535. Okay? How much will the account be worth in 2 years? So we have $500, hope I'm not standing in front of my writing here, times 1.07 raised to the second. And we have 572.45. So you take 1 point, you can do it this way. 500 times, open paren, 1.07, yx2, close paren, equals 572.45. All right, how about in 3 years? $500 times 1.07 raised to the third, and you get 612.52. So once again, 500 times, open paren, 1.07, yx3, close paren, equals $612.52. All right, so let's erase this. Not the best eraser. Whew, come on now. Is that all you got? All right, use the formula to solve the following. $1,000 invested at 4% for 5 years. 1,000 times 1.04 raised to the fifth, and that is 12, 16, 65. Okay? $1,200 invested at 5% for 8 years. 1,200 times open paren 1.05 yx 8 close paren equals 1772.95. And lastly, 1,200 invested at 8% for 20 years. And you get 55.93.15. There you have it. All right. Let's see if this marker is a little darker. Hopefully it is. All right, next. Why must you input a cash outflow as a negative number when you're using the financial keys on the calculator to solve a time value of money problem? So you have to input either the inflow or the outflow as a negative number, because the logic of the calculator requires either the present value or the future value to be entered as a negative number. Otherwise, you cannot solve for the interest rate, which is IY, or for N. Okay? So, if there's a beginning amount and an ending amount, the beginning amount, if it's a future value problem, the beginning amount is the amount that you must put into an investment. It is an amount that comes out of your pocket and goes into an account. Out of your pocket, it's an outflow, so you have to change the sign to a negative number so that when you say compute future value, you will get a positive number. Speaking of that, okay, so let's go on to question 6, and then question 7 has some more problems that we'll solve here. So question 6. How must you adjust the rate of return or interest you input into the calculator when you are using the financial keys to solve a time value of money problem? Well, you must multiply the decimal by 100. Okay? For example, if the IY is 5%, then the way you enter it into IY is 0.05 times 100, which is 5. 5 IY. Okay, so you have to take the percentage, multiply it by 100. All right, solve the following using the financial keys. Show the steps to input the data. So let's pull this up out of the notebook. And so what is the future value of $1,000 invested at 4% for 5 years? Now there are two ways you can solve this. One is to use the formula. The other is to use the financial keys on the calculator. So it's $1,000, and that's plus, minus, change the sign, present value. And 0.04 times 100 equals 4 is your IY. Okay, and 5 is your N. Compute future value, and you get 12, 16, 65. Okay? All right, let's do the next one. Future value of 1,200 invested 5% for 8 years. So just to show you that it doesn't matter what the order that you enter the information, we're going to put 0.05 times 100 equals 5, which is your IY, and 8 is your N, and 1,200 plus minus is your present value. Compute future value, and you get 1772.95. It doesn't matter what order this goes in. The last two keystrokes compute what you're solving for. Okay. Future value of $1,200 invested at 8% for 20 years. 20 is your N, and 1,200 plus minus is your present value, and 0.08 times 100 equals 8, which is your IY. Compute future value, and you get 5593.15. Okay, I might have missed that one when I can't remember if I covered it, so I'll just throw this on here. 1,200 times 1.08 raised to the 20th. 5593.15. There you go. All right. So that is homework 1, and I'll get this posted, and we'll jump into homework 2 in just a second.